Hello students, welcome to the module number 2. The second half of the module will start now. That is first law of thermodynamics. In that we are going to learn about Joule's experiment, equivalence of heat and work, and statement of the first law of thermodynamics, extension of the first law of thermodynamics to the non-cyclic process, and energy. Okay, so we'll start the Joule's experiment. See, first of all, what is meant by thermodynamics first law says that energy it is dependent upon the conservation law. That is, energy neither be created nor be destroyed, but it can be converted into one form into another form. So the scientist Joule found that from the basic concept of this, and is conduct one experiment. That is that experimental setup consists of an insulated cylindrical calorimeter with a spindle consisting of parallel weight, pulley, string thermometer, and handle. Okay, this known mass of the quantity was taken in the calorimeter, and you can see the arrangement in the figure. So both sides are weights are considered here, and water they have taken inside this calorimeter, and it is well insulated, and it is pedal will be provided, and to steering action to be take place, and here pulley and connect to the weights, and thermometer is also provided to know the known temperature of the water before and after steering action. Okay, so what happened, by rotating the handle the weights were raised through a height of a certain height, that is h. So again by rotating the handle in the reverse direction, what happened, the weights were allowed to fall down through the same height, that is h. So the falling of the weights rotated by spindle and thereby stirring the weight water contained the calorimeter. As a result, mechanical energy was converted into a heat, and the temperature of the water is also increased. So what happened during this stirring action, the mechanical work has to be done. So work has to be done. So by the sole weight is lifting against the gravity, what happened, so the due to the rising of heat, it is going to be rise the weight against the gravity. So that is what mechanical energy is converted into heat. So due to this rotation of pedal, this is one condition. Due to this lifting of weight, what happened, the stirrer action is taking place, and heat energy is going to be formed. So that will be noted by the thermometer. The process was repeated for different rise in temperature for each case, and found that the work is also transferred directly proportional to the heat transfer. By conducting this experiment or series of experiment, Joules found that the following weights lost the 4.18 kilojoules of mechanical energy, a temperature of 1 kg of water rise by the 1 degree centigrade. So this is the value what we called now, that is 4.18 kilojoules. That is what the mechanical equivalent of heat. Okay, so thus the potential energy of this falling the mass was converted into kinetic energy and finally into a heat energy. This is how they are conduct the experiment. Okay, so finally for the concentration that is mechanical heat equivalent is going to be taken, that is 4.186 kilojoule. This value we will call it as mechanical equivalent of heat. Okay, so next one we'll discuss the first law applied to a closed system undergoing non-cyclic process. Suppose if you consider a system having a heat transfer, and it will perform a work transfer. So if system undergoes change of state during which both heat transfer and work transfer are involved, then the net energy transfer will be stored or accumulated within the system. That energy we call it as total energy. Okay, that is we call it as generally there is energy, but mainly we consider as that energy we call as internal energy. That is Q minus W is equal to delta E. Okay. So that is the energy in storage in neither heat nor work, but it's given in the name of internal energy. So whatever the heat transfer and work transfer in between that, whatever the remaining energy will be there, so that we call it as internal energy. I hope you understand this topics. So let us discuss in the further topic in the next slide. Thank you.